Hello everyone. Today we are going to see about the links as discussed in the previous lectures about nodes, emitters, extended period simulation, graphical representation. So today we are focusing on links. So in this lecture for this particular tutorial I have created a quick and short network where the source has elevation of 0 and there is a tank which is at a height of 30 meters and there is one demand node in between. Okay, so what we are trying to do, we are trying to lift the water from 0 to 30 meters. Okay, with the help of pump. Definitely the specifications and use of pumps I will cover in the future lectures, but as of now I'll tell you that I have drawn a pump curve. Okay, so here in the curves I have drawn a pump curve which can give me sufficient discharge up to the height of 30 meters. This is one demand node. Okay, and definitely it's a tank. So all this water is being conveyed with the help of links. So suppose this is link, this is one of the links which has pipe ID of 3. So in the links, what are the important parameters? Length, diameter, roughness, and its initial status. So today we'll be only focusing on this initial status of the links. When I run the simulation, I get the output of flow, velocity, unit head loss, reaction time if there is some quality check, water quality analysis. Okay, so let us start with the problem. So EPANET takes not just the pipes as links but even the pumps and even the valves is considered as links in EPANET. Okay, so I have shown you a quick parameters of the links. So suppose if I close this link, suppose if I close the link, so what happens? Let us first adjust the flow arrows so that you can clearly see. Okay, so what is happening, the flow is going from here to this point and from this tank to this node. Okay, but the pipe as of now is closed, and if I run the program, you'll see that negative pressure is generated at 10 a.m onwards. That is because I have set the values of pumps in such a manner that after 10 a.m the pump shuts off. There is no power supply after 10 a.m. Okay, that's why. And one important thing is, if I close the valve, or sorry, if I close the pipe, you cannot see the arrow, the flow arrow vanishes, but here you can see the pump arrow, the pipe arrow, which clearly identifies which pipes are closed. Okay, again if I open the pipe, you can see the run is successful and you can see the flow arrow. That means the pipe status is open. So you don't have to, for bigger networks, you don't have to check for each and every pipe. You can clearly identify with the help of the flow arrows. Okay, I hope you are getting it from where I have got this flow arrows. Flow arrows, filled, fancy, whatever is suitable for you. Okay. The third option is CV, that is check valve or control valve. So what is the purpose of this check valve or control valve? So this CV controls the flow in only one direction. This is very important. It only controls the flow in one direction. Suppose if I have drawn the link from this node to this tank, so it will only allow the flow from this node to this tank. Okay, I hope you are getting my point. This is only allowing one-way flow. So if I run the program by changing the status to control valve or check valve, sorry, so it shows me a negative report, that is the negative pressure at 10 a.m, 11 a.m and so on up to 24 hours. That means what is happening in this network, so up to 10 a.m the pump the pump is on. That means the demand is getting satisfied up to this point, and even the tank is getting filled up to 10 a.m. Okay, but after 10 a.m. what happens? The pump shuts off. Due to this check valve, the flow can only be go into the tank, it cannot come out of the tank. So after 10 a.m. what happens? The pump stops working, so here there is no path for fulfilling the demand. Again from the tank, what happens? There is no flow because of this check valve. Okay, so suppose if we draw a graphical representation, I hope you know the graphical representation. If you don't know, you can go into my previous lecture where I have explained all the graphical representation for different parameters, even different types of graphical representations. So you can see the system flow. Okay, red one is produced one and the green one is consumed. So the red one is only available till 10 a.m. After 10 a.m. there is a sudden drop and the pump stops working. That means there is no water inflow into the network, and due to this control valve there is no inflow into the junction itself. So the demand is not getting fulfilled at this particular junction. So you can see the pressure is sufficient, or even it is showing 0. We have to change the scale. That is because very heavy negative pressure is there. That's why it is not showing clearly. Okay, just for our understanding, we can see after 10 a.m. the pressure suddenly reduces, and it reduces to a very negative value. That is because there is no supply. But again, if I open this check valve, open, so you can see the run is successful. And if I again plot the time series for pressure at this particular node, yeah. So what happens here when the pipe is open and the flow is allowed in all the directions? So the pressure goes on reducing up to 10 a.m. but not that abruptly. It is having a very small slope. That is because the pump is on, so the demand is getting fulfilled because of the pump. But once the pump shuts off, the tank is supplying the water to this node. That's why the pressure is getting reduced, and even the tank level is also getting reduced. So if you see the tank level graph, yes, node number 2 and the demand node are showing almost similar patterns. It is but natural because there is only single node and we are providing the water through tank. So I hope you have understood the use of this check valve, which is allowing water only in one direction. Again, you can see there is a warning. But I want to tell you one more thing. I have adjusted the controls of the network. That is, I have adjusted link 1 closed at 10 a.m. I have set this command line. That means after 10 a.m. link 1, which is a pump, will not work, or it will be closed. Even we can change the status of pipes as well. The pump series will be covered in the next lecture, so that you can better understand as to how this is working. But as of now, you only focus on this control check valve. Thank you.